Lately, there's been a huge growth in using infrared structured light. All right, in infrared structured light, one of the nice things about it is you and I can't see it. So it's doing all this stuff out there, but it's not sort of interfering with our vision. And the main reason that IR structured light has become so big is because of this puppy right here, the Microsoft Kinect. All right. Kudos to my friends and colleagues in England and Cambridge who helped take the technology, and it was the 3D technology that I'll tell you about was actually developed by PrimeSense, which was an Israeli company, and then Microsoft leveraged it in a way to go from the depth to recovering skeleton, which is a whole other interesting piece of work that we won't talk about here, but if we did it in machine learning, since they use machine learning methods for doing it, we could talk more about doing that. But the Kinect is really, I mean, it was $150, so all of a sudden you could put depth sensors on little experimental robots for very little money. So how does the Kinect work? Well, it's not public, all right? So there are people who know exactly how Kinect works, people from PrimeSense, et cetera, but it's not public. Lots and lots of this stuff is known, but the exact implementations are not known. The PrimeSense patents describe at least two ways, and I will tell you about both of those ways. Conventional wisdom is that one of the ways is actually used in the Kinect and one is not. I don't really care. They're both kind of interesting. So the two methods that they use, one is a very, very clever optics trick. In fact, it's so clever I don't totally understand exactly how it works because I have to get more into detail. But essentially, it projects a pattern with two different kinds of lenses, and we'll talk more about it in a minute, that allows you to go directly from the image to the depth. We'll explain that. And then the much more standard way, which is just like light striping, is that you're essentially using something about the projected image from the projection of a particular pattern in what it's observed like in the other camera. So you're about to see some drawings that look kind of funky. They don't look like, you know, the high quality drawings that Megan always insists that I use. But that's because these are actually taken directly from the patent and the patent applications. I think it's cool to just see those. So the key to the Kinect, the key to the PrimeSense focus method are these cylindrical lenses. So cylindrical lenses, if you take two of them, and you have one that goes one way, and I think on the next thing, you have one goes the other way, you end up with this funny situation where you have different focal lengths depending upon which way you move. So you have one focal length horizontally and a different focal length vertically, and of course slightly different focal lengths as you were to sort of rotate around. What this allows them to do is to project out speckles, and now what happens when a dot is out of focus? Well, in a normal lens, right, it becomes a blurry circle. When you have one of these, what are called astigmatic or asymmetric lenses, it becomes an ellipse because the lenses are different in one direction than they are in another direction. And what's cool about the way they did this geometry, and this is the part that I'd have to work through the math more to understand, is that depending upon the depth, so here the hand is at one Z and here's at another Z, again, these are from the patent, these ellipses, well, they have different thickness, but more importantly, they have different orientations. So you can just take a look at the orientation in a little local area of these little dots that have been smeared, and the orientation tells you the depth. This is really, really cool. But I think it's so cool that they probably don't use it, because I think it requires some pretty precise lensing and some other things. I'm not really sure. But this is the one method of how the Kinect works. And if you go in their patent, you'll see figures that talk about like this, that you capture this test image and then you find the range based upon the pattern orientation. And then you build this 3D map. Although you notice this says based on offsets between test and reference pattern. So that's the method I'm about to tell you. Here's the one that just talks about the orientation.